In this video, I will show you how to convert square wave from a 50 Hz drive board to sine wave at the output. By using a couple of self-made drive boards, 6 MOSFETs of IRF3205, a modified microwave oven transformer, and others etc. Step by step in the details. This PCB is self-designed and manufactured by JLC PCB. It has just arrived. Those parts will be soldered on the PCB. On its completion, it acts as SPWM pulse shaping in the actual circuit. The soldering works has been completed. The pin on the left is for the DC positive, the one on the right is for the DC negative or ground. The pins in the middle are for the inputs of this circuit's board. The output pins of this circuit's board are here. This is a DC power indicator. It will be on when the DC power is on. This is 50 Hz square wave drive board. Its details can be obtained by watching this video on my channel. That's the SPWM pulse shaping circuits board, which is just made. The black wire is for the DC negative, red wire is for the DC positive, which will be 12 volt. And so are those wires for this board. A couple of these wires are for the outputs from this board, and will be connected to the inputs from the SPWM pulse shaping circuits board. For the convenience, they are fixed on the wood board and secured by screws. The 50 Hz square wave board is here. And the pulse shaping circuits board is next to it. The positive wires from two boards are joined together. And so do the negative wires. Those are the inputs wires from the pulse shaping board, and the outputs wires from the 50 Hz square wave board have been soldered together. Here is their circuits diagram combined. The output of this circuit combined has been hooked by a mini oscilloscope to show their output waveform. Connected the DC power, then the LED is indicating. The mini scope is showing the series square wave with horizontal movement, which is two circuit combined result. It comes from the square wave duty cycle changing simultaneously. Disconnected the power off now. This is the MOSFET pack, pre-soldered together, and screwed on a heatsink. 3 of these are as the one group, their drain terminals contact the heatsink. 3 of those are as the another group, however their drain terminals don't contact the heatsink. The twin twisted wires, which soldered on their drain terminals instead. Each resistor has the same value as 10 ohms, which soldered on each gate terminal. They are connected in parallel as a group. And so has this group. This wire soldered on the left group resistors. That wire soldered on the right group resistors. A couple of these wires will be connected to the output pins of the pulse shaping circuits board. The thick black wire is the DC negative, or ground, which has been soldered on source terminals of all MOSFETs. As a DIY inverter, all things will be installed on this board. This microwave oven transformer has been modified. The center tap terminal is here. The primary terminals are this and that one. Input, or primary winding, is double 12 turns. The wire can withstand maximum 30 amperes. The output fixed to a 3-pin AC socket here. Between the output terminals, a rating of a 2.5 μF and 450 volt capacitor connected. This is a 40 amperes fuse, a 2200 μF and 35 volt capacitor installed there. That's a mini switch. This arrow will be installed the square wave and SPWM pulse shaping circuits boards combined. That area will be installed the MOSFETs and heatsink pack. A pair of the battery cables and alligators will be secured around here. Here we go, all done, and this is the parts, or components connected diagram. That square thing from the diagram is the drive and pulse shaping circuits boards combined. Those from the diagram is the MOSFETs and heatsink pack, just right over here. The modified transformer from the diagram, which installed on the board here. A 3-pin socket is the AC output, as mentioned previously. Those are the secured points from the diagram for a pair of the battery cables and alligators, installed here. 2 capital letter B, marked here and there, from the diagram, it is actually a twin twist wires connected between the fuse bracket and the center tap terminal. This wire from the diagram is actually the red thin wire from the drive boards combined, connected to the switch socket, then to the fuse bracket here. That wire from the diagram is the black thin wire from the drive boards combined to the DC negative, or ground. Those of 2 output from the drive boards combined, connected to gates resistors side of the MOSFETs group accordingly. This wire is the drain terminals from 3 MOSFETs on the left, connected to the one of the primary terminal on the top, by a screw. However, that wire is the drain terminals from the right, connected to the other primary terminal by a twin twist wire along here, and screwed on the wood board. 2 of capacitors connected in parallel between the output of the AC terminals, which its total value is 2.5 mF, as mentioned previously. The final output of the AC waveform will be almost perfect sine wave. Now, the DC 12 volt has been connected, but switched on yet. A multimeter has been hooked to the output AC terminals. And so has a mini oscilloscope. This test run will not be any load connected on. Switch the power on, then the LED is indicating. AC 241 volt is indicating by the multimeter. The output waveform looks like this. Smooth sine wave. Switched the power off. That's it. Now you've known how to convert square wave to sine wave, then made a sine wave inverter. In this one of the ways. Thank you for watching. Please like, share, comment, and subscribe if you have enjoyed the video. Your encouragement is my motivation.